Alrighty. Lesson 70, we're getting up there, solving radical equations. In the expression, the cubed root of x, 3 is referred to as the what? This might be a little less known to you guys. That number that goes up in the radical, that is called the index. That refers to what root you are taking. Simplify. Square root of 64, 8. Simplify the cubed root of negative 125. It'll be negative 5. And then lastly, we need to solve. Whoops. Let's group those together real quick. So in order to solve, I am going to subtract 6 from both sides. So we have x squared plus 5x minus 36 equals 0. And then what multiplies to get negative 36 adds up to get positive 5. That would be x plus 9 and x minus 4 equals 0. So then the actual roots there, or the zeros, would be x is equal to 4 or negative 9 if you solve for each of those. Okay? A radical equation is an equation that contains at least one radical whose radicand contains a variable. So radical equations over here, you can see every x value is underneath the radical. So on the right hand side, we have radical numbers or irrational numbers, but the variable is outside of that, so it's not going to be a radical equation. To solve radical equations, first isolate the radical on one side of the equation, then raise both sides of the equation to the power of the index of the radical. This will clear the radical. It is critical that the solutions of a radical equation be checked because some of the solutions obtained may be extraneous solutions. An extraneous solution is a solution of a derived equation that is not a solution of the original equation. So we will be checking for those as we go. So solve each equation. The very first one we got here, square root of x minus 5 is equal to 14. As they said, we will raise both sides because that is already isolated. So we have x minus 5 is equal to 14 squared. 14 squared gives us 196. And then add 5 to both sides. So we get 201. Check our solution. 201 minus 5, square root of that, is that equal to 14? Well, 201 minus 5 gives us 196. Square root of 196 would be 14, so that works out. Now the next one. Remember, we have to isolate our radical. So we're going to do minus 3, square root of 6x plus 7 is equal to 6. Square both sides. 6x plus 7 is equal to 36. Minus 7, 6x is equal to 29. I don't know about this. Divide by 6, divide by 6. So that would be 29/6. Let's check it though, just in case. Square root of 6 times 29/6 plus 7 plus 3 outside is equal to 9. So our 6's will cancel out, so we get 29. This is actually should work out. So 29 plus 7 gives us 36. Square root of 36 is 6 plus 3 equals 9. That is true. That works out for us. All right, moving right along here. Even though we have a higher power, that is totally fine. We will solve it the exact same way. So first thing we need to do is isolate. We don't want to close. So the cubed root of 4x plus 4 is equal to 6. We're going to cube both sides. 6 times 6 times 6, I believe, is 216. Yes. So 4x plus 4 is equal to 216 minus 4 from both sides. 4x is equal to 212, and then we want to divide by 4. So 212 divided by 4, this will be a 5, 1, 2, don't know what I'm doing there, 53. Let's check that, plug her in. 53 times 4 would give us 212. Plus 4 is 216, cubed root of that, 6 minus 6 is 0. Works out. Next one over here, divide by negative 2, divide by negative 2. Cubed root of x minus 3 is equal to negative 7. Cube both sides. X minus 3 is equal to negative 7 cubed. Negative 7 cubed is equal to negative 343. Plus 3 plus 3, x equals negative 340. So let's see. If I plug that in, negative 2 cubed root of negative. Yeah, that'll work out too. So cubed root of negative 340 minus 3, negative 343, we get negative 7. Negative 7 times negative 2 is going to be equal to 14. So that one works out as well. Jump into our next one. Sometimes an equation has two radicals. If their indices, or plural of index, are the same, and each radical is on a different side of the equation, it is simplest to raise each side of the equation to the power of the index. If the indices of the radicals differ, the solution can be estimated by using a graphing calculator. Graphing calculators are also very useful in checking solutions. So we'll be looking at how to do that as well. So here, like they said, both would have the same index here. These are both just square roots, so we can square both sides immediately. That gives us 8x minus 5 is equal to 4x plus 5. So minus 4x from both sides, and add 15 to both sides. So we get 4x is equal to 20. Boom, boom. Oh, whoops. So x equals 5. Check your answer. If we're going to check it graphically, let's hide this graphing calculator. The way that we will do this is I'm going to graph both of them separately. So square root of 8x minus 15, and then the square root of 4x plus 5. And I'm going to need to zoom. Let's do standard. That looks a little better. Now, where these two things cross, if I want to find that intersection, I can do second, calculate. That fifth option there is intersect, so I'm going to hit that. My first curve, you want to get somewhere close to where you think they may be intersecting. There we go. Boom. Second curve, take a guess. There we go. Intersection is at x equals 5, which is what we came up with. So that's a good thing. X equals 5, we checked it. Good to go. All right, now this time we have a cubed root on both sides, and we actually have a number that is outside of our radical. That doesn't really change the way that we solve them. In order to get at our variables, we would have to cube both sides. Now this right-hand side, we end up evaluating a tiny bit differently. So this first side, we have just 3x is equal to Now here we take 2 cubed, we all know is 8. Then we have the cubed root of x minus 1. So we get that. And then from here, we can just distribute that 8 before we continue to solve. So we get 3x is equal to 8x minus 8. Let's go right ahead and subtract that 8x from both sides. So we get negative 5x is equal to negative 8. Divide by negative 5 from both sides. So we get x is equal to positive 8 over 5. So 8 over 5, let's think of that. So that would be 1.6. Let's see if we get that same thing if we graph. Remember, a cubed root can be in the math. Fourth option there. So we get 3x. Clear that out. 2 times cubed root of x minus 1. Cubed root function kind of looks like a propeller. That jumped up or right around 1, so I'm assuming that those are going to intersect at 1.6. And actually, just to show that, because I believe I already know what it is, I can say 1.6, and I guess I should actually do the intersection. It looks like that is the point. First curve, second curve. There you go, 1.6. That's the intersection. Checked it, good to go. Okay, now let's solve if we have 2 different roots. Now for this, all I want to do is get rid of this guy right here. So I just want to move that over to the other side. I can't really solve this algebraically in an easy way. So the way that I'm going to go about this is just doing what we have been doing to check our answer. But I'm going to add that to both sides. So plus the cubed root of negative 5x. So because I have these two things set equal to one another, I can set them up as different functions in my calculator. So again, if I go back in here, the first one, the cubed root of negative 5x. Now our second function, we have the square root of 2x minus 6 outside of our radical. See, here's our cubed root function, that kind of propeller shape. Has rotational symmetry, and there's our square root function, which is just kind of one piece of it. So if I want to find the intersection, we'll do that same method. Let's get over close by that intersection point. There you go. That intersection is at 4.8-ish, 4.83. What we get there. Almost done, I promise. When we look at this problem, we should be getting red flags right away. Let's solve for x first. So add 4, add 4. So get the square root of x is equal to negative 4. So we're solving for extraneous solutions. So one thing we should realize that in this problem, we're looking for that. We're going to have it. But before I even finish this, I have the square root of something is equal to a negative. I should already know that that's not possible. But since we're solving for extraneous, let's finish up and solve. So we would get x is equal to 16. Okay, now let's plug that back into our equation. The square root of 16 minus 4 is equal to negative 8. Well, I know the square root of 16 is equal to 4. minus 4 is not equal to negative 8. Okay, so that's why this is extraneous. That does not work out for us. Same problem. The period of a pendulum, T. If you guys don't know what a pendulum, think of like a grandfather clock, or maybe like a Newton's cradle or something like that. Each of those could be kind of described as a pendulum, just something that goes back and forth. Is the time it takes for the pendulum to make a back and forth swing, and is given by T is equal to 2 pi times the square root of L over 9.8, where L is the length of the pendulum in meters. Find the length of a pendulum whose period is 3 seconds. So we already know that this goes with T, so T equals 3. So I'm going to plug in a 3, and I'm going to solve this equation backwards. So we're going to divide by 2 pi. over 2 pi is equal to the square root of L over 9.8. We will square both sides. Put that in parentheses so we know everything is being squared. So then 3 squared is 9. 2 pi squared. I'm just going to actually say 2 pi squared, or yeah, I'm going to leave it as that, is equal to L over 9.8. I'll use a calculator to find a value, but I don't really want to get rounding error. So L is equal to 9.8 times 9 over 2 pi squared. So let's figure out a value for that. Quit out of here. 9 times 9.8 equals 2.23 meters, that would be. So that pendulum would be 2.23 meters long. Okay, that's all I have for you guys today. Hope you were able to follow along. Hope you were able to get some notes down. If not, I suggest that you watch this again, pause it as you go, try some of the problems out before I do them, so on and so forth. But I hope you guys have a great day.